This is a 3D printed Iron Man helmet. The helmet is equipped with a rechargeable power bank that drives 10 unique servos used to articulate multiple sections of the faceplate. An Arduino Nano is used to run all the electronics and sequence of the servos. And I can't wait to show you how I made it. Let's go. What's up, you guys? My name is Mark and welcome to my channel. I downloaded this design for free from Thingiverse and will have a link to the files in the description below. I've been doing a lot of printing lately and I'm getting really sick of sanding, so for this build I decided to have PCBWay print the majority of the files for me in black and white resin. PCBWay can print parts in metal, resin, PLA, ABS, TPU, as well as many other types of materials. They have an automatic quoting process, so you'll know exactly what you're paying for, and the quality is fantastic. I recommend checking them out if you don't mind paying a little bit more for guaranteed smooth and clean prints. For this specific build, the parts cost a total of about $150 after shipping. There are also a lot of smaller parts that I printed in PLA on my printers at home. The parts arrived super well packed. I couldn't believe the amount of bubble wrap and packing material they wrapped these parts in. Rest assured, if you decide to order parts from PCBWay, they should not come damaged. It took a bit to unwrap everything, but after I did, I had to admire how smooth these parts were. This is huge for me because the most time-consuming part of all my builds is always sanding. I don't need to sand any of these parts and can go right to applying primer. However, before I do that, I assemble all the pieces of the helmet to make sure that everything fits together properly. This design uses M2 and M3 screws to fasten pieces together, which makes it really easy to assemble and disassemble the mask. I found that a lot of the holes for the M2 screws were a bit big and my screws weren't grabbing, so I used a drill to widen the holes and used M3 screws instead. Everything ended up fitting together great. You can see on the inside of the mask where all the servos will be mounted and just how much time and effort was put into this design. Okay, now it is finally time to add primer. I apply one coat of primer evenly over the front and back of every piece. I will be painting the inside and outside of the mask because I want to show off how cool all the electronics look after everything is installed and put together. After the pieces have dried for 24 hours, I lightly sand them with 800 grit all the way up to 2000 grit sandpaper. As I move up in grit size, I incorporate wet sanding to keep the sandpaper from clogging. I only sand the outer side of all my pieces because the interior finish isn't as important to me and it saves me time because, as you all know, I hate sanding. After all the parts are sanded, I use chrome spray paint from Revell to coat all the pieces of the faceplate. The Revell chrome spray paint is the best I've ever used, but it's also $35 a can. So if you're okay with a metallic but not mirror-like finish, you can definitely use a different brand of chrome paint. I cover the rest of the helmet with Duplicolor metallic red. After the red paint is dry, I also add a few layers of Duplicolor clear coat. Do not add clear coat to your chrome paint because it will become foggy and will lose its mirror-like qualities. After everything is painted, I start working on the electronics. The designer of this build has step-by-step instructions on exactly how to wire things up, as well as a wiring diagram that lays everything out. All I can say is use your resources and be thankful that somebody has already done a lot of the heavy lifting for you. I'll have a link to the wiring guide and the exact items to purchase in the description below. I start by wiring all the connections to the Arduino Nano. I connect a black wire to the ground terminal and split it 3 ways to be used as ground for the LED eyes, switch, and servo board. I connect a green wire to the D2 terminal that will be used as one of the wires to the switch, and a yellow wire to D6 that will be connected to the positive wire coming from the LED eyes. I connect a red, yellow, and green wire to the A4, A5, and 5-volt terminals respectively. All of these wires will be used to connect the Arduino to the servo board. Next, I attach a 2200 microfarad capacitor to the ground and VIN pins on the Arduino board, as well as a black and red wire that will connect the Arduino to the power supply. The capacitor is used to reduce electrical noise and help stabilize the voltage from the power supply. I use JST quick connectors on all my wires, which makes it a lot easier to connect and disconnect the circuit for testing and installation. The servo board can be wired in a similar way. I connect a black, yellow, green, and red wire to the ground, SCL, SDA, and VCC pins on the servo board respectively. These 4 wires will be merged with the JST connector and will attach the servo board to the Arduino. A red wire is connected to the V+ pin and a black wire is connected to ground. These 2 wires will be used to connect the servo board to the power supply. I attached 3 of the headers supplied with a servo board as well as another 2200 microfarad capacitor to the plus and minus C2 terminal. After the servo board is wired up, it should look like this. The rest of the wiring consists of 2 slide switches that will be installed between each board and the power supply. One of the switches will control the LED eyes and the other will turn the Arduino on and off. A limit switch will be used to activate the servos and run the code. The battery pack is cut from the LED eyes and a JST quick connector is installed so they can attach right to the Arduino board. 2 USB cords are also cut and installed with JST quick connectors. In addition to all of this, the wires from each of the servos will either need to be cut or extended. The designer has a table with the appropriate wire lengths for each of the servos in the wiring diagram. Just take your time and keep things organized. Have a plan and know what you need to do before cutting and soldering. It'll keep you from making mistakes. Now, before I can connect everything to test it, I need to upload the code to the Arduino. The code can be downloaded from Thingiverse along with the 3D files. The code is already done for you, so it's really just as simple as dropping it into Arduino IDE and uploading it to the board. I did run into one issue when uploading the code, which was making sure the correct board is selected. Since I'm using an Arduino Nano Every and not a regular Arduino Nano, I needed to download the Mega AVR boards package from the boards manager. This allowed me to select Arduino Nano Every as my board and choose my programmer. After the Arduino is programmed, the entire circuit can be connected to verify that the code is running as it should. When the limit switch is pressed, the LED eyes should light up and all 10 servos should be activated at different times. I had footage showing all of this, but I can't find it anywhere and I must have lost it. Sometimes I can be a knucklehead. Anyway, my test confirmed that everything was wired up correctly and the code was executing just as it should. Now that the wiring is done, the code is uploaded, and the helmet is painted, it's time to put everything together. In addition to the wiring guide, the designer was nice enough to prepare a build guide as well with step-by-step instructions on how to install everything. The guide can be downloaded from Thingiverse, but I'll also have a link to it in the description below. I start by using 2 M3 bolts to attach Dome 3 and 4 together. Dome 2 can be added by using 4 more M3 bolts. The chin, jaw, and mouth can be attached together using another 6 bolts. Once the jaw assembly is completed, it can be attached to the dome assembly. Now, this entire assembly can be put off to the side while the faceplate and electronics are installed. I use 4 M2 bolts to attach the servo board to the top of the dome. I attach a wing servo to the top of the helmet, followed by a main arm and main brow piece. I verify the placement by activating the servo and repeat the same steps on the other side of the helmet. I attach the center bracket to the 2 main brow pieces and install 2 servos for both brow side pieces. I connect the brow side pieces and activate the servos. I remove the center bracket because the rest of the face assembly will be easier to build separately. I attach a servo for the center brow piece. After verifying the servo activates correctly, I attach another servo to the center mount for the center nose piece. I install 2 more servos on the center nose piece that will be responsible for activating the side nose pieces. The last 2 servos are attached to the side nose pieces and will activate the cheek pieces. I reattach the center mount to the top of the helmet and verify the mask opens properly. I screw the flexible LED eyes to the eye frames and trim the excess flexible plastic. I screw both eye pieces to the center mount in the faceplate. The last step is installing wire guides to the inside of the faceplate to help with wire management. Now that the faceplate is done, I install both slide switches to the chin of the helmet, followed by the limit switch. I screw the Arduino board to the back of the helmet and install a bracket that holds the rechargeable battery. I install zip ties to help with the wire management inside the helmet and install covers to hide some of the wiring. And with that, the build is complete, and here is the final result. Thank you guys so much for watching. If you enjoyed this video, please give it a like and subscribe for more content. I'll see you next time, and stay classy.